Hello, class. Welcome to Chapter 1, where we're going to talk about linear equations and linear functions. Our first video here is going to start in section 1.1. The first section will actually cover our class as well. And this is about using what we call qualitative graphs to describe situations. So we'll define what qualitative graphs are. And when I say describe situations, it's just like I'm going to give you a problem. All right, and I'm going to say, well, here's there's two variables. And how are they related? And then what we're going to want to do is show a mathematical graph that describes that situation. And that'll make more sense as we go through the video and our lecture. Okay, so first off, what is a qualitative graph? Well, a qualitative graph is just a graph without scaling. When I say without scaling, that means without tick marks and their numbers on the axis. So when you're used to seeing a graph, what you're used to seeing is the XY coordinates, and then you'd see these little tick marks on the x-axis, the x-axis, and the y-axis. And those tick marks would represent some type of scaling, like every 1, every 2, every 5, whatever. For these qualitative graphs, we don't do that. All we use these graphs for are to just basically generally describe a situation. All right, so let me give you an example, all right, of some type of qualitative graph in a situation. All right, so imagine this. For children whose parents earn I dollars per year, so I is representative like their income, the income that people make per year, all right? So we have that variable I, and let P be the percentage of the children who attend college, okay? What that means is, okay, if a family makes $50,000 a year, okay, imagine all the families in the country who make exactly $50,000 a year. What percentage P of those children will attend college? Is it like 50%, 60%? I'm not exactly sure. All right, so the qualitative graph that we see below, all right, displayed describes the relationship that I think there is between income and the percentage of people, the percentage of children who attend college. All right, so looking at this graph, what does it tell us? Well, just looking here, I have one axis here that's labeled I, so this is the dollars they make per year. And I have another axis labeled P, which is the percentage of those children whose family makes that much goes to college. And then I have this blue line here. And what we're seeing here is the blue line is supposed to represent the relationship between dollars that the family makes per year and the percentage that go to college. All right, so the graph or this curve tells us that the higher the income, so as income goes up, all right, what we see here is the relationship is also telling me goes up. It says the greater percentage of the children will attend college. So as income rises, a larger percentage will attend college. And I think that makes sense. And that's all this graph is showing, all right? That as income rises, the percentage of children who go to college also rises. That's all a qualitative graph does. It takes that, what we thought the relationship was between I and P, income and percentage who go to college, and shows it in some type of graphical relationship. Okay, so once we have these graphs, we notice here that we have two variables, one called I and one called P. We wanted to find out what are called explanatory and response variables. So assume that an authentic situation like income and percentage to go to college can be described by using variables, I don't know, we'll call them whatever, T and P. And assume that T affects or explains P. Then we call T the explanatory variable or the independent variable, and we call P the response variable or dependent variable. Like, let me go back here. So something called an explanatory and a response. Looking at this relationship here, I think the income explains the percentage of people who go to college. So that means I would be the explanatory or independent variable, all right, or independent variable, and P would be the response variable of the dependent. So explanatory explains, so the P responds to it. So this is my response variable or dependent variable P. All right, let's do an example of identifying these explanatory and response variables. So for each situation below, identify the explanatory variable and the response variable. Okay, so you're waiting in line to go to a concert. Okay, whatever, just imagine you're in line at the gate to go to a concert. Let T be the number of minutes you must wait. right, to get into the concert, and let n be the number of people ahead of you when you first get in line. All right, so which variable, n or t, do you think explains the other one? All right, well, let me ask you this as you're watching this video. Do you think the number of people in line ahead of you will affect or explain or determine the amount of time that you're going to spend waiting? I think so. So the more people ahead of you when you first get in line, the more time you must wait. Okay, that makes sense. So the number of people ahead of you, n, that n variable, affects or explains your wait time t. So n is the explanatory variable and t is the response time. Okay, so another way to think about it is your wait time does not affect the number of people ahead of you. Okay, so it doesn't make sense reading it that way. Let's try another one. Right? Let n be the number of times a person can lift dumbbells that weigh W pounds. All right, so do you think the number of times you lift something affects its weight, or the weight will affect the number of times you can lift it? Well, the heavier the dumbbells, the fewer times the person can lift them. I can relate to that directly. Right? The dumbbell's weight then affects or explains the number of times that the person can lift them, n. So we're able to say W is the explanatory variable and n is the response variable here. Okay, so the number of times the person can lift the dumbbell, right, does not affect their weight, as I was saying before. All right, so when you're graphing, right, we're going to start or describe how you might make your own graphs. All right, for graphs, we describe the values of the explanatory variable on the horizontal axis always. Right, so those independent explanatory variables are on the horizontal axis, and the values of the response variable here go along the vertical axis. So these are the dependents. So think about it as the x and the y, right? All right, so let's describe the meaning of a qualitative graph here with an example, all right? So I'm going to give you another one here. So let A be the average age in years when men first marry, so the average age that men first get married, and let T be the number of years since 1900. This is important. I want to talk about this now. When you see things like T be the number of years since 1900, that's going to come up a lot in this class. So for example, when I say, well, T is equal to 1, what year does that represent? Well, that's 1 year since 1900, so that's the year 1901. So on the graph here, the origin or starting point here, that would be 0 years since 1900. Okay, so that would be, 1900. If you have T is equal to 100, might be somewhere out here. That would be 100 years since 1900 or the year 2000. Right? The graph below describes the relationship between the variables. Here we have T, right, the year since 1900, and the variable A, the age at which a person gets married. Right? What does this graph tell us? So look at this graph. Right? It's trying to explain a situation. Right? And well, it looks like as the years since 1900 move forward or increase, the average age that men get married, it goes down, and then something happens at a certain point in time, and it starts to go back up again. All right, well, the graph tells us that the average age when men first married decreased each year for a while. We don't know for how long it kept decreasing, and then increased after that. I think that makes sense if you think about it in terms of society. I didn't get married till I was 36. So that's pretty late compared to my father's generation. My father got married in his early 20s. So for whatever reason, societal pressure or societal reasons, people are getting married older nowadays. And that's what this graph is attempting to show. All right, this curve here, this curve that looks like a U, right, this is what we call a parabola. And we'll learn about parabolas much later in the class. We're going to spend a lot of time, at least in chapters 1 and chapters 2, just talking about linear or straight lines. All right, I want to talk now about intercepts of a curve. All right, so the point of intersection is what we call an intercept. So here, like where this intercepts the A axis, this is called the A intercept. So an intercept of a curve is a point where the curve and the axis or axes intersect. All right, so 2 or more examples are shown here in this figure to the right. So we have the W-axis. So where this line crosses the W-axis, this is called the W-intercept. Where this line crosses the T-intercept, that's called, or the T-axis, excuse me, That's called the t-intercept. All right, so just wherever the graph crosses an axis, those are what's called the intercept. If it crosses the a-axis, that's the a-intercept. If it crosses the t-axis, that's the t-intercept. All right, let's do some examples of sketching a qualitative graph. All right, so let's see. So I'm giving you some variable, be the cost in dollars of a 30-second ad during the Super Bowl at T years since 1987. All right. So just think about like how big the Super Bowl has gotten and probably what's gone on for the cost of buying these ads, right? These 30-second commercials, right? So for most years, the annual increase in cost is more than the previous annual increase in cost, right? So what that means is the cost is skyrocketing, right? If the cost 2 years ago changed $1,000, well, that doesn't mean it's going to be another $1,000 change this next year. It's going to go up even more. So sketch a qualitative graph that describes the relationship between this C and T. Okay. All right, so because the year affects or explains the cost of the ad, T is the explanatory variable. And I just want to pause. And if you're going to remember one thing from this video that's going to come up a lot in this class, whenever you have two variables and one of the variables is time, 99% of the time will be the explanatory variable. Okay, so just keep that in your mind. Time is usually the explanatory variable. All right, so time is explaining C here is the response variable. Okay, so time explains that cost is going up. So we let the horizontal axis, all right, because that's the explanatory variable, be the t-axis, and the vertical axis be the c-axis, the dollars it costs. Because ads were not free in 1987, we don't start it at zero. I mean, ads cost something. So their dollar amount would start up on the axis a little bit here. All right, and the c-intercept, to explain that they did cost something and not zero, is above the origin. And costs are increasing. So we sketch a curve that goes upward to the right, because that's what increasing means. Because most increases are more than the previous year, there should be a bend, like I tried to explain before, that the costs are like accelerating. So it should curve more or bend upward from left to right. So this is what's attempting to show the cost of increase of those commercials. As years since 1987 have gone up, costs have gone way up as well. All right, what does it mean to be increasing and decreasing? So if a curve goes upwards from left to right, so as I move left to right, the curve goes upwards, it's increasing. All right, if the curve goes downwards as I go left to right, so as I go left to right, the curve goes downwards, it's decreasing. All right, so increasing goes up, decreasing goes down, if that helps to think about it. All right, let's talk again about sketching a qualitative graph. All right, so suppose the latest Radiohead album, so just an old band, Radiohead, is about to be released. Let N be the number of albums that will be sold if A dollars are spent on advertising. All right, so to sketch the qualitative graph that describes the relationship between these variables A and N. All right, so the first thing you have to think, I've got these two variables. N is the number of albums sold. A is the dollar spent on advertising. Right? Which one is going to explain the other one? Right? Do you think the number of albums sold explains the dollars or the amount spent on advertising? Or do you think advertising dollars help explain the number of albums that are sold? Well, what I think here is the amount of money spent on advertising affects or explains the number of albums sold. So let's let the horizontal axis then be the a-axis and the vertical axis be the n-axis. So I would first start by sketching my two axes. All right. I know that A is the explanatory, so I'm going to put the A down here, and the number of albums sold are up here. And I would describe the relationship with this type of graph. All right, so because both N and A must be non-negative, right? Why? Because you can't spend negative dollars on advertising, and you can't sell negative albums, right? The qualitative graph is in that first quadrant. All right, so notice how I first have the number of albums sold up here, right? Not down at zero, up here. All right, so even if no money is spent on advertising, some people are still going to buy the Radiohead album. Doesn't matter if there's no advertising. So the n-intercept should be above the origin, right? The more money spent on advertising, the greater the sales. So the curve should be increasing. But here's the thing: there are only so many people. However, no matter how much you spend on advertising, that would buy the album no matter what. So the curve has to level off. All right, so meaning if they were to spend $1 trillion in advertising, they're not just going to keep selling and selling advertising. It's going to level off. So they're going to spend money on advertising. Those first advertising dollars are going to help out a lot. And then once you reach a certain point of advertising dollars, it's just going to tail off and you're not going to help sales anymore. So that's how I would draw this. All right, so I talked about the quadrants before. There are 4 quadrants to a graph when you draw your axes, right? This is quadrant 1, and then it goes counterclockwise, quadrant 2, quadrant 3, quadrant 4. In quadrant 1, all right, both variables are positive. In quadrant 2, the explanatory variable is negative, but the response variable is positive. In quadrant 3, they're both negative values. And in quadrant 4, the explanatory variable is positive, yet the response variable is negative. All right, we're going to spend most of our time in this class, the vast majority of the time when we talk about modeling or describing situations in quadrant 1, however. All right, I want to talk about when you're writing a good response to questions, or if I ask you to describe a situation, how you would want to write about it, okay? And this will come up when we do journal assignments, things like that in this class. All right, so the first thing you want to do is create an example that illustrates the concept or outlines the procedure that I'm asking you to write about. All right, looking at examples or exercises, especially in the textbook, may jumpstart you into creating your own example. All right, always use complete sentences and correct terminology. Describe the key ideas or steps for your example. And you can review, as I said above, the text for ideas, but you have to write your own description in your own words when you're writing. All right, describe also the concept or procedure in general without referring to your example. All right, it may help to reflect on several examples and what they all have in common when you're writing. All right, in some cases, it will be helpful to point out the similarities and differences between the concepts or the procedures you are describing and other concepts or procedures. And describe the benefits of knowing the concept or the procedure. That's important as well. All right, if you have described the steps of the procedure, explain why it's permissible to follow these steps. All right, clarify any common understandings or misunderstandings about the concept, or discuss how to avoid making common mistakes when following procedures. Always describe the meaning of the explanatory variable and the response variable. That's incredibly important. Like, what does it mean when I'm saying dollars? It's an income per year. And when I say the percentage, I wanted to talk about the percentage of students going to college. Make sure you explain that as well. All right, assume that an situation can be described by using variables. Doesn't matter what you call them, T and A, and that T affects or explains A, then T is always going to be the explanatory variable, and A is always going to be the response variable. All right, so for example, as I was saying, let A be the amount of money in dollars that a person is paid for working T hours at a gasoline station. Well, obviously, the more hours you work, the more money you make. So then T is the explanatory variable and A is the response variable. All right, why? Well, because the number of hours worked affects or explains the pay that somebody will make. And for graphs, remember to use the horizontal axis to describe values of the explanatory variable and the vertical axis to describe values of the response variable. All right, class, that's our first video for chapter 1, and more will be posted for the remaining section shortly.